In the last couple of videos, I introduced you to inheritance and how it works with a class hierarchy. I talked about the base class, also called the superclass, and subclasses. I also demonstrated overriding methods and gave you a quick look at how inheritance plays into polymorphism in Java. Maybe you're thinking that inheritance looks kind of interesting, but when would you really use it? Well, it turns out in Java you've been using inheritance all along without even knowing it. This is because every class you create in Java actually extends a special Java class. That class is named Object, and it's in the java.lang package. Okay, that's confusing. A class called Object. Let's see what Java has to say about this class. We'll use the link to Java's Application Programming Interface API for this class, which you can find in the resources section of this video. There it is, the class object. Class object is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. Whether you knew it or not, your classes were extending the object class. They all inherit from object. And what that means is that all of your classes have functionality built in that you can use or override the minute you create them. Let's explore the methods on java.lang.object. We can select the method tab from the summary list. And here you can see some of the methods on object like clone and equals. And also here is one I just showed in the last couple of videos, the toString method. Every class we create or use is automatically inheriting from this Java supplied class called object. Let's get back to some code in IntelliJ to see this in action. For this video, I've created a project called the object class and created the main class with main method. I've said every class inherits from object, and this actually includes the main class. How can we tell? We can use the code generation tools, and you can see that by opening up your generate command. If you go to override methods, you can see when I've done that brings up this select methods to override or to implement pop-up. As you can see, these are all methods. The M stands for method. These are all methods that are inherited from java.lang.object, which is a class. All classes you create automatically extend object. That's equivalent, essentially, to typing extends java.lang.object. So I'll do that in my main class. I could also just omit the package name java.lang and just say my class extends object. At the end of this section, I'll be talking more about packages. Let me do that. For now, I'll just say that Java has a way of implicitly doing things that make our jobs easier. One of these is to include all objects from its core libraries automatically, so we can refer to them like I am doing here, as simply object without the package name. The other is to implicitly have all classes extend this object class that do not explicitly extend from another class. Just to be clear, I can show this on a class diagram. This slide shows that my main class inherits from or is a subclass of object, as is also the case with string, a class you are pretty familiar with already. This slide shows the methods on object and main and just a few of the methods on string. The string class has over 60 methods. In alphabetical order, these methods start with one called char at and end with one called value of. The string class overrides several methods on object, two of which are equals, which I'll be discussing in our lecture on all things string, and toString, which I used in the previous lectures. All objects, including arrays, inherit the methods of the object class. It's really important to know this happens automatically. Now I'll double-click object in the code and right-click the mouse to bring up options. I can select Go To and then Declarations or Usage. This is the Control-B key combination for Windows users. This displays the actual source code of the class, in this case object.java, which is inherited automatically when I create any class, as we discussed earlier in the video. You can see as I scroll down that I'll go through some of these methods. I see hash code and the equals method, which compares one type of object to another. This has a lot of detail about the implementation of each of these methods. In general, there are very specific times you'll be overriding these methods, and I'll be showing you examples as we proceed through the course. There's also toString, which it says is just a way to return a string representation of a specific object. Let's explore the string a little more using main.java. I'll close object.java first. I'll add a new class in main.java itself and I'll call it student. Remember, only one class in a Java source file can be public, and since I've already made main public, I won't make student public. class student. I'll start by adding some fields. Private string name, private int age. That's a simple class named student with a name and an age. Let's add a constructor so I can quickly pass data to the class when I create it. Student, and in parentheses, two parameters, string, name, and int age. This .name equals name. This .age equals age. Next, I'll create an instance of student in my main method and print student out. Student max equals new student, and in parentheses, my arguments passed will be max and 21. I'll use println and call max.toString, and running that code, I get student at 65 AB 7765. You might get something different, but that's fine, and I'll explain why soon. What is that? Well, the code in the toString method in the object class prints out the class name, which in my case is student, followed by an @ sign, then the hash code of the object. A hash code is an integer that is unique to an instance in the currently executing code. As you can see, the display isn't showing an integer, rather it's a hexadecimal number. I won't get into why Java is showing an integer as a hexadecimal number, other than to say it's for debugging purposes. What's important is that the hash code is created every time an instance is created. We will talk most about hash codes later in the course. By looking at the hash code, we can determine if multiple references are pointing to a single instance. It's a mechanism for comparison, in other words. This really is like an address for a house, which I talked about in my examples, to explain the difference between references and objects or instances. Anyway, this isn't what I want printed out. I really want to print out the name and age of my student. And I've done this before, but now I hope it's becoming clear what I'm doing. I'm overriding the toString method on object. I'll now do that on student. First, I'll just type public and then 2 in lowercase, and notice IntelliJ has popped up choices I could select. I'll pick that first option. And now I have a toString method that simply calls super.toString. Do you think that does anything different? Maybe you'll remember I've said that calling a method on super like this without doing anything else is kind of redundant. I'll confirm that by running the code, and I get the same result. I've really just explicitly called the code that Java would have implicitly done for me. I'll comment that code out and try the other option next. Again, I'll type public and 2, then pick the second option, which has generate via wizard in it. And this should look familiar. This brings up IntelliJ's code generation window for the toString method, and I'll select both fields and hit OK. I've done this before. I'm simply specifying for this class what I want to print out. Running this code now gives me the student class name, but now in curly braces. I can see this object has name equals max and age equals 21. I'll change this and just simplify it. I don't really care that the class name is student. I'll comment out the default generated code, simply return the student name and say how old they are, return name plus is and the age. And now if I run that, I get max as 21. You make this code be whatever you want it to be when the toString method is called on your class. You may also remember that I told you Java implicitly calls the toString method on an object if you simply pass your object to println. Let's confirm that by remove the toString method call. Here I simply pass the maxStudent object to the println method on system.out. And if I run that, I can confirm that this code is really calling the toString method on student, and max is 21 is still printed out. What happens if I now have another class that extends student? Let's create a primary school student class, which would be a student who is aged 5 to 12, for example, in the elementary or primary school, and this student will have a parent name associated with it. For the sake of simplicity, I'll just include one parent. Let's look at a class diagram. I've already built student, which inherits from object implicitly. Next, I'll build primary school student, which will inherit from student. Let's add this new class. Class primary school student extends student. I'll add private string parent name. I'll add a constructor, and the parameters will be string name, int age, and string parent name. I'll invoke super, passing name, and age, and use this to assign parent name to the field in this class of the same name, and complete the constructor and class definitions with right braces. Hopefully you understand what I'm doing here with this code. I've created a primary school student class that extends student. I've added an attribute specific to a primary school student and called it parent name. And I've set up a constructor with 3 fields, the 2 fields I had for student, name and age, and now parent's name as well. I call super with name and age in parentheses to call student's constructor, and I set the parent name to the argument with the same name. Let's create a primary school student in the main class. I'll name him Jimmy, and his parent will be Carol. Primary school student Jimmy equals new primary school student, passing Jimmy as I mentioned, 8 for age, and Carol as the parent. I'll use println to invoke the toString method on the Jimmy object. And running that, you can see that I get Jimmy as 8 as the output for this code. This code inherited student's toString method code. And now I can override toString again, this time on primary school student. Here, I'll return the parent name and then call the toString method on student with the super keyword. And when I run that, I get the output Carol's kid, Jimmy is 8. In this case, super.toString didn't call object's toString method, it called students. But it still inherits object's other functionality indirectly through student. Java only supports one class in the extends class. For example, I couldn't type student then object. This is a compile error. The inheritance tree is cumulative, meaning that primary school student inherits both student members and object members. Object members are accessible as long as student doesn't override them. Because student overrode toString, I no longer can simply call the toString implementation on object from primary school student. I'll revert that last change and I'll end the video here. In this video, we learned that all classes which do not explicitly extend another class will implicitly extend a class named object. Object is the base class or root class of every class in Java, which means all classes can use or override objects' methods. Next, I want to give you a challenge on inheritance. I'll see you in that next video.